and welcome to another MTK webinar. My name is Hussain Al-Kamali and I'm currently teaching maths in the international stream at MTK school named in the honor of Haidar Aliyev. I'm going to go over the basics of algebra, and I'd just like to give you a bit of a history behind why it's called algebra and why we always use X when it comes to algebra. So a long time ago, thousands of years ago, there was a man called Algebraic, and he was of Persian Babylonian descent. So he was half Persian and half Babylonian, Persia being Iran, Babylonia being Iraq. And he would say to people, Shay plus 3 equals 10. Shay meaning something plus 3 equals 10. So something is 7. Or Shay plus 7 equals 17. So something plus 7 equals 17. So that something is 10. So he would go around speaking this to people, but they wouldn't understand exactly what he was trying to explain. So instead of him being understood, they would say he was speaking gibberish. Hence the term gibberish when someone is talking that you don't understand. So over time, his knowledge got passed over from Persian Babylonia, from the Arab world to Europe, where it went to Spain. And in Spain, they wrote Shay as XSAY. So they wrote XSAY plus 12 equals 24, or XSAY plus 15 equals 30, and so on. But over time, they stopped using the letters XSAY and just wrote X. So X plus 4 equals 6, or X plus 12 equals 17. And that is why algebra is named algebra. It's named after Al-Jabbar, and X is synonymous with algebra. That's why it's always used. You're always thinking of X when you hear the word algebra. So that's a bit of a historical reference to algebra. Now, let's go over some of the basics. So this term here, for example, it shows something plus y equals 17. So that something here is 8, because 8 is the unknown. This symbol is an unknown. An unknown plus 9 equals 17. So 8 plus 9 will equal 17. And another example is this one here. So something minus something else equals 5. Now these two letters are unknowns as well. These two symbols, sorry, are unknowns as well. We don't know what these two are, but they could be many different things. So any two terms that subtract to get 5 is acceptable. So in this case, 12 minus 7 can equal 5. 3 minus 2 minus 1.8, because the two minuses there will become positive, will equal 5. And you can use any different types, like 16 minus 11, 18 minus 13, 7 minus 2, 5 minus 0. They could be any two terms you like, subtracted together as long as the final answer is equal to 5. So these two are called variables. They can be different numbers. They're variables. They're different possibilities for these two symbols. In algebra, we don't usually use symbols. We use letters to represent the numbers. So the unknowns or variables are letters. That's generally the way it is. It's easier to write and more understandable. So sometimes we can work out the value of the letters and sometimes we can't. So in this example here, n plus 3. So n is a variable, but it could be any number. And 3 is always going to be plus 3. So any number plus 3. So in this case, this is not a because n can be any letter, any number, sorry, it wants. And there's no equal sign here. So that is called an expression. So for example, if John had a packet of biscuits, sorry, and he doesn't know how many biscuits it contains, we will use the term B to represent the biscuits when it's full. So if he were to eat 4 biscuits out of the packet. We don't know how many biscuits are in the packet, but we know there are a full pack of biscuits is represented by B. If he eats 4 of those biscuits from the packet, it will be B minus 4. So this is an expression used in the real world. We don't know how many biscuits there are, but he's eaten 4. So you will say the pack of biscuits full minus 4 is the expression for what has happened. Another example, for example, is if John counts the number of biscuits in the packet, and after he has eaten them, there are 22. We can write an equation for this. So using the expression from the previous example, it was B minus 4. But now we know B minus 4 equals 22. So when we know there are 22 biscuits left after he's eaten 4, we can find out how many biscuits there are in total. So if B minus 4 equals 22, and we added 4 biscuits to the 22 that were already there, we'll find out that B is equal to 26. So a full packet of biscuits is 26 if after 4 are eaten, there are 22. So this is an equation. An equation always has to have an equal sign. If there is no equal sign, like in the previous example, and it just said B minus 4, then it is an expression. So just bear in mind, an expression is a letter plus or minus a number, or it could just be the letter by itself. But in equation, you always have to have an equal sign. So a letter minus a number, or a number minus a letter, equals another number or a letter. It will automatically be called an equation. Okay, so those are the big 2 differences there between an expression and an equation. So that means there were 26 biscuits in the full packet. So when we write expressions in algebra, we don't usually use the multiplication sign symbol either, as it gets quite confusing since the multiplication sign and x are very similar. So for example, if we were to write 5 multiplied by n or n multiplied by 5, we don't usually write this all together. We'll just write 5n, and this automatically is understood as 5 times n. So the number must be written before the letter as well. It's not wrong to write n5, but generally, as a rule of thumb, mathematicians usually put the number first and the letter second. So when we multiply a number or symbol by 1, we don't have to write the number 1 either. So if it's 1 times n or n times 1, we generally just write n, as we know 1n and n are the same. It's the same as saying if you have an apple or if you have 1 apple. You don't generally say I have 1 apple, I have a apple, and it will be accepted as being 1 apple. So when we write expressions in algebra, we don't usually use the division sign either. Instead, we use the line over a number or letter. So in this example, n divided by 3, you can write it as n over 3 as a fraction. It makes life a lot easier when you're writing them like this, because it could be n plus 1 over 3 or n plus 6 over 3 plus 5n. It's a lot more straightforward when you write them as fractions. That is generally the rule of thumb again when it comes to division. And when we multiply a letter symbol by itself, we use something called index notation or indices. So in this example here, n multiplied by n is n squared. The same as 2 multiplied by 2 is 4 or 2 squared. In that case, you have the numbers and you know what they equal. In this case, we have variables n and n. We don't know what they are, so we can't use it as a number, but we can use it as a letter. So n times n is equal to n to the power of 2 or n squared. So in these examples here, we have algebraic expressions, and we're being asked to find out what these expressions are written as. So the first one, a number n plus 7. So it'll be n plus 7. In the second one, it says 5 minus a number n. Now it says 5 first, and then minus a number n. So you have to write 5 minus n. If you wrote n minus 5, that wouldn't be the same thing. If, for example, we assumed the letter n was 6, 5 minus 6 would equal negative 1. But if we put 6 at the beginning and minus from 5, it would be 6 minus 5, which would equal 1, which is not the same as negative 1. In this third example, it says 2 lots of the number n, or 2 multiplied by n. Now we know you can write 2n, but generally when we're doing algebraic expressions, we write 2n. Same for the second one here. It says 6 divided by a number n. So we know it's 6 divided by n. Now, as I said before with the second expression, it was 5 minus a number n. It's 5, then minus, then n. In this case, it's 6 over n. So 6 is going to be the numerator, and n is going to be the denominator. So it'll be 6 over n. The next one, it says 4 lots of a number n plus 5. So you're going to multiply n by 4 and then add 5 to it. So you write, as we've shown in the third example, it was 2 lots of n. In this case, it's 4 lots of n, so it'll be 4n and then plus 5. In the third example, in the sixth example, it says a number n multiplied by itself twice, or n times n times n. So we know here n times n was n to the power of 2, or n squared. If you're multiplying it by itself 3 times, then that power is going to be 1, 2, 3, 3 n's, so it'll be n to the power of 3. And finally, the most challenging one, it says a number n plus 4 and then times 3. Now, if you wrote n plus 4 multiplied by 3, you would know through BIDMAS, you would do the multiplication first and then the addition. So it would be n plus 4 times 3, which would be n plus 12. But in this case, it's saying n plus 4 first and then times it by 3. So it'll be n plus 4 in brackets and then multiplied by 3. You can write the multiplied by 3 at the front or at the end, or you can just simply write 3 times n plus 4. So those are different types of expressions you could do when you're asked to write them out. In this case, it says Miss Green is holding n number of cubes in her hand. So you don't know how many cubes she has, but you've represented it by the letter n. And there you're asked, write an expression for the number of cubes in her hand if. So it's similar to the biscuit analogy. If she takes 3 cubes away, you will know that n is the total number of cubes and you subtracted 3 from it, so it'll be n minus 3. The next example, it says, what about if she doubles the number of cubes she is holding? So you know n is 1 set, so if you multiplied it by 2 or added n plus n, you would get 2n. So it would be 2n, or 2 multiplied by n, or n plus n. Each of those are acceptable, but you generally write that as 2n. Now in these examples here, we have equivalent expressions. So 2 of these are the same. So 2n, you know, is going to be n times n. N divided by 2 divided by n is going to be 2 divided by n. These 2 and 3 match. 2n minus n is going to be the same as n. N divided by 2 is going to be the same as n over 2. N plus 2 is the same as 2 plus n, and n times n is the same as n squared. So these are all equivalent expressions and written in different ways. Now, when 2 expressions are equivalent, we can link them with a triple equal sign. That means they're the exact same. So if you wrote x plus x plus x, that would equal 3x, but they're equivalent, they're exactly the same. So you put 3 equal signs in front. Another one is called an identity. So in an identity, the expressions on each side of the equation are equal for all values of the unknown. So this is called an identity. So if you wrote x as 5, 5 plus 5 plus 5 is 15, the same as 3 times 5, which is 15. Or if you made x 7, 7 plus 7 plus 7 is equal to 7 times 3. So these are called identities. They're identical in what they do, and whatever you make the letter to be equal to, it will be the same on both sides, and they will match. The expression is said to be identically equal, hence the term identity. It's short for identically equal. So in algebraic expressions, they're made up of terms and operators. Operators are positive, plus, minus, multiply, divide, and brackets. So a term is made up of numbers and letters, but not operators. So 3a plus 4b minus a plus 5 is an expression, as we discussed previously. You can have any number of letters and numbers, but they do not have an equal sign. They're called expressions. 3a, 4b, a, and the number 5 are the terms within the expression. So the terms make up what is in the expression. So each singular one, 3a plus 4b minus a and 5, are all terms within the expression. So the terms make up the expression. 3a and a are called like terms because they both contain a number and a letter symbol. So a and 3a are like terms. 4b and 5 are not like terms because you do not know what the letter b represents. So the letters which are the same are classed as like terms. So terms make up an expression, and the like terms are the ones where the letters are the same. So in algebra, letters stand for numbers. So we can use them as the same rules as we do for arithmetic. So if we were told 5 plus 5 plus 5 plus 5 equals 4 times 5, the same would be said about a plus a plus a plus a. That would be 4a. So they're identical again. So the a's are like terms, and you collect together the like terms to simplify the expression. Both are correct, but if you were asked to simplify a plus a plus a plus a, it would be 4a. So in an expression, you always want to add the like terms together to simplify it, and you do that by collecting the like terms. So in the expression here, you have 3a plus 2b plus 4a plus 6b. Now you know the a's are like terms and the b's are like terms. So you add the a's together, so it'll be 3a plus 4a, which is 7a, and you add the b's together, 2b plus 6b, which is equal to 8b. And again, the expression cannot be simplified any further because the a's and b's can represent different numbers, and they generally will if they're different letters. So a can represent a number and b will represent a different number. So 7 multiplied a number plus 8 multiplied by a number. And again, expressions do not make you know what the letters are. You just leave your answer as that. For the first example, we have a plus a plus a plus a plus a. So you know there are 5 a's altogether, so you simply write 5a. For the second one, it's 5b minus 4b. So 5 minus 4 is 1, so it's simply b, or you could write 1b. For the third example, you have 4c plus 3d plus 3 minus 2c plus 6 minus t. Now you have two like terms here in 4c and minus 2c, so they will equal 2c. 3d plus minus d, so those are the two like terms there. And then you have the whole numbers 3 and 6, which don't have any letters, so they're also like terms. When you put them together, you have 4c minus 2c, which is 2c, 3d minus d, which is 2d, and 3 plus 6, which is 9. And finally, the last example, it says 4n plus n squared minus 3n. Now, n and n squared, the power of 2 and an n, because those numbers will be different. So, for example, any number apart from 1, if you were to say n was 2, 4 times 2 minus 3 times 2, that would be 12 minus 6, which would be 6. But if you added the n squared to this, it would be 4 and not 2 that you're adding. So you leave the n squared aside as it's not classed as a like term. If the powers on the letters are not the same, then the numbers are not going to be equivalent. So you simply do 4n minus 3n, and n squared is a different like term. So it'll be 4n minus 3n, which is 1n, and n squared. The last example, it says 4r plus 6s minus t. Now you know from this there are 3 different letters, so there are no like terms. So you cannot simplify that any further. So you simply leave that as 4r plus 6x minus t. Now algebra could also be used for lengths and widths and finding perimeters. So in this question here, it's asking you to find the perimeter of this rectangle. Now you know this side at the top is 2a, and the other side underneath it is going to be 2a. And the side to the right, the width is 3b, so the width on the other side is 3b. So it will be 2a plus 2a and 3b plus 3b, as the sides are identical. So 2a plus 2a is 4a, and 3b plus 3b is 6b. So this side at the top, the length is 2a, and the other length will be equivalent, so it'll be 2a, and the width is 3b, and the width on the other side is 3b. So that's finding an expression for the perimeter of that rectangle. Another one is if you were given a quadrilateral. This quadrilateral, you have 4 sides again, 4y, 2 5x's, and 1x. So when you get out, it's 4y plus 5x plus x. Now the y is not a like term of any of the other x terms, so it'll stay the same. But 5x plus x plus 5x, these are all like terms. So you'll add them all together, and it'll be 4y plus 11x. So in algebra, we usually leave out the multiplication sign. Any numbers must be written at the front of it, and all the letters should be written in alphabetical order. Now that's also very important. Again, it doesn't mean that it's incorrect if you wrote them in non-alphabetical order, but it's just something that is usually done. So 4 times a, as we've explained, you write the number first and the letter second. So it'll be 4a. 1 times b, as we explained previously, you don't really need to write the number 1, you can just write it as b. Now 5 times b, or b times 5, again, it's going to be 5b. You don't usually write it as b5, although it's also correct. And the fourth example, it's 3 times d times c. Now, as we stated in the beginning, it said you usually write them in alphabetical order. So you'd write it as 3cd and not 3dc. It's accepted, but that doesn't necessarily mean that is what's done. So usually when you write the expressions or you see expressions, they usually write it in alphabetical order from A to Z. And the last example here, it says 6 times E times E. So you know 6 times E times E, it's going to be 6e to the power of 2, as there's 2 e's there. So it's going to be e to the power of 2 times 6. You write the number first, and then e to the power of 2. In this example, as we stated previously, there are 5 x's there, so you simply write 5x. Now, if you wrote x times x times x times x times x times x, so you're multiplying x by 5 times by itself, it won't be 5x, because when you add them, it's 5x. When you multiply them, it's going to be x to the power of 5, and this is called index notation or indices. So when you multiply the same letter by itself, the power of that letter increases by the number of letters there are. So in this case, you've got 5 x's, so it'll be x to the power of 5. And in the top example, it was x plus x plus x plus x plus x. So there's 5 x's added together, it's 5x. So the key difference here is when you add the x's, you have to increase the number in front of the letter, but when you multiply the letter, you increase the number that the letter is to the power of. So x times x is x squared, x times itself 3 times is x to the power of 3, and x times itself 4 times is x to the power of 4. So when you multiply the letter by itself, the power increases, and it depends on how many times you've multiplied the letter by itself. So in these examples, you've multiplied it by 2, 3, and 4, and 5. So you can also use index notation to simplify expressions. So in this case, you're multiplying 3p by 2p. So it's 3 times 2 is 6, and p times p is p to the power of 2. Again, if you're multiplying q to the power of 2 by q to the power of 3, it's like saying q times itself 5 times, and it'll be q to the power of 5. And again, if you're multiplying 3r by r squared, it's like saying 3 times r times itself 3 times, which will be 3r to the power of 3. And lastly, if you multiply 2t times 2t, it's essentially going to be 2t to the power of 2, or 4t squared. So when you're multiplying the powers, you simply look at the letter and the power, and then you add the powers together. So in this case, in this first example, it was 3p to the power of 1 times 2p to the power of 1. So it's p to the power of 1 times p to the power of 1, which will be p squared. You're simply adding the powers. So q2 times q3, you've added the 2 plus 3, so it's going to be 5. In algebra, we do not usually use the division sign, as I previously stated. Instead, we write the number or term we are dividing by underneath, like a fraction. So in this example here, a plus b divided by c, you'd write a plus b at the top and put it over c. So it'll be a plus b all over c. Okay, so that was the last thing I was going to go over. I've just gone over a brief understanding of how we use terms in algebra and where algebra came from, why x is so synonymous with it, and how to add and subtract different terms in algebra. I hope you enjoyed this lesson, and I hope to see you soon next time. Thank you very much, and goodbye.